In this Mathematica Sessions video Q&A, I go through some questions from one of my online students in microeconomics and show him how to use Mathematica and get better at it. So this is from an elementary point of view. So if you're interested in that, keep watching.
Hey, Sam, how are you?
I'm well, thanks.
Sorry, the video, I'll have to get it fixed up later. I'm sorry about that.
I'll share screen, I think. So it starts here. All right, so let's have a look at your first question. Now, as I scroll through this, I can see why you want to invert a function, right? Because you want to display a function of price with the axes reversed,
Yeah.
right?
Yeah.
Is that correct?
Yeah, that's correct.
Yeah. So when I studied mathematical economics a long time ago, I found that such a pain that it's backwards. So, I mean, you must be a little bit confused about it too. Anyway, those guys went that convention, so you got to live with it. All right, so you've defined two functions here.
Yeah.
F of x, you've got minus 2x plus 50, and then you calculated the inverse function. Yeah. So first thing I want to tell you, now that's correct, right? First thing I need to tell you, though, is that the inverse doesn't always exist. And you probably know this, right? Yeah?
No, I didn't know that, no.
All right, so I'll just give you some details on it. I won't go into too much detail. So you've got to test whether the function is one-to-one. So basically, if, and I'll just put this under here as a comment, if the function f is 1-to-1, then an inverse function exists. Okay, so you need to know what 1-to-1 means.
Yeah.
And basically, the rough definition is basically, so 1-to-1 means, and I'll copy and paste this here for you. Basically, every horizontal line passes through the curve at most one. So a circle, for example, that's not 1-to-1, okay? Because if you take a horizontal line through a circle, you've got two intersections, right? And so the problem there is that if you were to reflect it and rotate it and reflect it like you're talking about below there, to plot one of the letters in terms of the others, that wouldn't work because the result wouldn't be a function, right? You'd have it going over the top of itself.
Yeah.
Again, another simple example that is not, and I'll just abbreviate it 1-to-1, 1 minus 1 to mean 1-to-1, is just y equals x squared. All right, so if you plot that, you get parabola, right? And if you pass a horizontal line through it, you have two intersections in various places, right? Yeah. And so if you were to rotate that, actually, you know what? I'll just plot it right here, right? So I'll plot both of them, and you can take note of how we do this, right? You already know how to do this kind of plot. So let's go x from -3 to 3, okay? So you can see horizontal lines go through twice. Yeah. But now if you do this another way, so let's go contour plot. Contour plot y equals x squared, and we'll do the same thing. so that you can see that you get the same result. All right, so here I have an equation. All right, I also need the y. Okay, now it works. So this is a contour plot, meaning that here I give the equation and then I just say plot that equation. It doesn't have to be a function, but I've got to give the x and y balance. Now, if you did that the other way around, you'd probably get what I'm trying to talk about. So if, for example, I put the y first, let's have a look at this. Yeah, this is what I mean, right? So this, the third one, do you see that?
Yeah.
The parabola on its side there. So that one, so this, if we think of the x-axis as the x-axis now, and the y-axis is vertical, this is not a function anymore because it goes over the top of itself. In other words, an input of the number 2 has an ambiguous output.
Yeah.
All right, so it's not a function. And so this one here does not have an inverse, right? So instead we call that a curve.
It fails the
so,
vertical
anyway,
line test of a function, yes?
Yeah, that's right. Yeah, exactly right. Because it fails the horizontal line test when it's the other way.
Yeah, okay.
So,
okay.
yeah, so that's right. So this one here, x squared, doesn't have an inverse, but you can restrict the domain from, say, 0. You can take the positive end of the function, and then that function does have an inverse because you just take the square root of y as its inverse function. All right, so you can restrict the domain so that it does have an inverse.
Okay.
But I guess we're probably getting too deep in that. We need to continue on, right? So your question now is, how do you use, so I'll take this down below. So your question there is, how do you use Mathematica to calculate your inverse function? Okay, so here I've just been playing around with code beforehand. And so let's just talk about this. All right, so here you've set a as this first function, right?
Yes.
And I put a semicolon out to suppress the output. Now let's just unsuppress these and look at them piece by piece. So I'll just cut them. Let's look at these two. So what I'm doing first is I've got a symbolic expression, right? So f is bright blue there, so it's not a number in memory. And then we've got x is a slightly, I guess, turquoise, and then I'm saying solve this equation for x. But what I want you to notice here is that I've got 2 equal signs. You see that?
Yes.
So that acts like a question, right? It's not you putting something into memory. It's, whereas if you have only 1 equal sign, you're putting something into memory. Like what you had up above, you're putting something into memory, but here you're treating this as a question. And so when you want to solve an equation, you can use this syntax here.
Yes.
Right, so we solve it. You can see the answer right here. But the problem is it's got these brackets around it that you don't want.
Yes.
Okay, so what I'm doing here with the double square brackets around what you put into memory as A is called indexing. I'm pulling out specific elements, right? And so I'll start with just the number 1. That picks out the first element, right? And you can see basically it pulls out the first element of that array, which is another array, okay? And now if you put comma 1, you'll pull out the first element of that array that you pulled out. So now you've got x goes to this thing, 50 minus f over 2. And so you can index on expressions like this as well. All right, now I say, I want to take the second one of this. So I just include another 2 after that, and I get this right-hand side of your inverse function there. Almost, right? We're not quite done. So did you follow that?
No.
No?
Just start from the
Okay, drop me an question.
No.
Start from the array, did you say?
Yeah, just start from just start from the array. Yeah, that'll do.
Okay, so with this one here, right? You see the output here, it's got the double brackets around it.
Yeah, double
this
brackets.
Is what happens when you just say solve the equation, right?
Okay.
But all of these numbers here, I'm pulling out the first one of this double bracket, which is what I'm going to highlight here, just the single bracket inside.
Yeah.
Right? So that's what happens when you put a 1. So I'll set this out line by line for you. And then we'll just call the last one equal to b.
Okay. Then.
Okay, so the first one here, it just gives you this with one bracket, meaning it takes just the first one of this outer array.
Yeah.
And the first one is just this array that says that, right? But now I've got another array, but I want to pull out the first one of that.
Yeah.
Okay, so we don't need the b there, but so I take that and I say pull out the first one of that. So I put comma 1. Okay, and that will give me the first one of that. But the first one of that is this thing that says x goes to, but it really means x equals this, right?
Okay.
In the output of solving.
Okay.
Now, what I want this piece, okay, so I can say, okay, take the second one of this expression, and you can see it's just that, right? So to do that, I just put a comma 2 there, and then that's the last one, right? So that's just this here that I've now got highlighted.
Okay.
Does it make sense now?
Yeah.
So I'm just trying to automate this.
Yeah?
For you. Yeah, I'm taking out brackets. That's right.
Okay.
And then in this one, I'm just pulling out the second thing in this expression, right? So that's what that 2 is for.
Yeah. Okay then.
All right. So now we've got that. It's now in memory as b. And now the next thing I want to say is change the name of f to x, right? And so I can do that just by replace all. Now, replace all is a command that allows you to just, everywhere you see the f, put an x instead, right? So that's what it does, but it allows you to do it without putting anything into memory.
Okay.
Right? Because otherwise you would say f equals x, and then you've got to go and delete that out of memory.
Yeah.
So this replace all lets you just make the switch. Okay, so let's see what it does. Now we've got 50 minus x all over 2, and that's the same as minus a half x plus 25, right, that you had above.
Yeah.
All right, and then if you actually want a function out of that, you can just set up the function just like what I have here. So we can just build this function now.
Yeah.
And I've just, this is the same as above there. So now you've got the function, and then we can just test it out. Does this work? G of 2, and yeah, we get 4. So it works, right? But I should tell you now that if you just wanted to plot that, all you have to do is just plot from this point. You don't have to actually build the function.
Okay.
So I'll just show you here, right? So plot uppercase G, and then we'll just choose some range. X goes from 0 to 4, for example. All right, and there you have your line.
Yeah.
Actually, you know what? We can even plot the inverse function as well.
Yeah.
And I'll just pull this one. We can plot the inverse function in the same graph. So just put that below so you can, I mean, because I know you're new at this, right? So you probably want to see any lines here as you can.
Yeah. Thanks.
Without overcomplicating things. So we've got the inverse function plotted. And then here we have f and its inverse functions. So I guess the orange one in this picture is the inverse function, and the blue one's the original one.
Yeah.
That's correct.
Yeah.
Hang on. Yeah, I guess so.
I just want to ask you again. So I followed it. The second round I did follow. I understood it a bit more, but let's have a look. On the right-hand side, you have A equals solve. And then you have the brackets f double equals, and then minus 2x plus 50, comma x, close bracket, semicolon. You can see that? In the
you're talking about on the right-hand side here?
Yeah, that's right, yeah.
Yeah.
And then when you run that, if you go back to your other Mathematica window on the left with this diagram, if you go back, and then you said that the output has two like braces. So there's 4 braces in total in the output 191. Okay.
Yeah, exactly.
And so what is this telling me? Output 191. What does that mean? An array.
Well, I mean, as a human, right? As a human that you are, you can just read the inside of it, and this is saying because you asked for it to solve this equation up here.
Yeah. For
x, it's done that. It's given you the expression of it's solved for x in terms of f, right?
Okay.
Because Mathematica can do symbolic stuff as well as programming, right? So it does a symbolic solving.
Yeah.
And gives you the result x as a function of f.
Yeah.
Right?
Yeah.
So that's what that is. And so you can just read the inside if you would be satisfied with that, right? And then you could just say, okay, I'm going to plot this with f in the plot range, right? Which is what you might want to do when you do your price and your quantity functions. You might want to just pull this out, leave the f as if, right, rather than actually calculate inverse function. Because when you calculate an inverse function, you represent it in terms of x, right?
Yeah.
But given having read ahead what you want to do next, you probably actually want to keep it in terms of the original letter and just plot it differently, right?
Okay. But
so I guess we'll come.
Okay, so
yeah.
So as a human, you're saying that you can read the 50 minus f divided by 2, and then
that's right.
And then what's your procedure again? You want to start removing the brackets. Why do you want to do that?
So, well, if you just wanted to automate the entire procedure, and build a function out of this, so that you could easily plot the inverse function, this is how you do it. You pull out that you want. You just follow the procedure that you would do on pen and paper for finding the inverse function, right?
Yeah.
Which is basically, I mean, the procedure on paper is solve for x in terms of y, and then change the name of y to x, and then you present your function as the inverse function, right?
Okay.
So I've just used a little piece of code to do all of that automatically for you. So that's what this is here.
Okay, I've had some additional questions with this particular question. I would like to I'd like to be able to show the slope and the horizontal and vertical intercepts for that function f equals minus 2x plus 50.
Okay, so so in this graph here, you'd like to show the slope, you say?
Yeah.
Okay, so well, the slope here, that'll be just a constant number, right? And so the slope in this function, minus 2, wasn't it? Yeah. So now you can do that with calculus here. So if we go down to another cell, I'll just show you. So you just take, and again, I'm trying to show you how to automate this procedure. It was 2x plus 50, okay? So I'm saying take the derivative of this with respect to x, and you get this number here, and you can even put that in memory as m. Okay, so m equals that. That's the slope of that function. What else did you want to display? Did you want to display that in the diagram?
Yeah, is that hard?
Yeah, show it on the graph. No, it's all right. Okay, so what I suggest we do though is do this in another cell because I don't want to overcomplicate what you've learned up in this cell.
Okay.
So I'll just grab this. Hang on. What did I want to grab this one? Okay, so we'll do a plot here. All right, so we've got this function. Let's put it in memory now as f. Actually, you know what? Let's go y, and then you can change it. And so here I can just call that y. Let's test it. Okay, good. We get the slope. Now what you want to do is plot. You want to plot the function. I guess that's y, and let's choose a plot range. X goes from 0 to, did you choose 25 originally, I thought? Something like that.
Yeah.
So here we've got our plot, okay, and now what you want to do is include some things in it, right? Now, I've got to have a quick look up on there of how we easily, I don't remember everything.
Yeah,
okay, so I'll just type in plot. And what I want to do is look at the options. So this is probably good for you to see what I do when I don't know something, right? In this language. So I've just plot, I'll scroll down. Now here we see an example. So what I've done, if I didn't do that in front of you, so I just open up the examples and I look at, okay, so here they've labeled something. So plot legends. So we could try this. Let's just copy and paste this out and put it here. Okay, see what happens. Well, nothing. Okay. All right, so I was expecting. Hang on. What happens if I do this? No, okay. All right, so we have plot labels. Have they got that in memory already? No. Okay. Plot labels. So we'll just change this to labels right here. All right, so here it's put a minus 2x plus 50 on the x-axis, which you don't quite want, right?
Yeah.
So yes, we can put x comma and then this. All right, so that's not quite what we wanted, is it? So here, what's plotted here is the line y equals x, and then this other one. And so it is labeling that. It's just unfortunate that it happens to show up on this, right? So I wonder if we can do something about that.
Yeah, extend the range.
As in maybe
the main, extend the main.
Yeah, if we go to make 30. There we go. So now this looks better, and I think we can just get rid of that bracket there. Okay, so now you've got that kind of labeled, if that's what you were after there.
Yeah.
But did you want the axis labeled as well? Because we can easily do that.
Okay, let's try that then.
Axis labels, I think. No, not quite sure about this, so I'll look in the options.
Yeah.
Axis, all right, let's have a look. Axis, is axis false? Okay, so we want the axis labels. Okay, so
it's without the S, maybe. Axis labeled.
Oh, right, you're right. Yeah, no. Okay, and so we can just put, I guess, X and Y. All right, so Y is in memory now, you see. so it appears as 50 minus 2x on the x-axis,
Yeah.
which you may not want, but of course, you could just not put that in memory, or we could just put an uppercase in this case and see, we'll get something else, right?
Okay.
Which is kind of okay. So you'll have to play around with that and see, you know, and look in the help file until you can perfect exactly what you're after there.
Sure.
So, did that answer this question?
Yeah, that's pretty good. I like that one. Thank you.
Okay, great. Great. Sure. All right. And so now let's have a go at your next one, if you're ready for your next question.
Yes.
All righty. So let's scroll down here. I'll save this. Okay, in microeconomics, demand of a good depends on the price. So basically, yeah, you've got the quantity demanded, as you say, depends on the price. So it's a function of the price. And so in maths, we would put the P on the horizontal axis, if that's the case.
Yes.
So you want it the other way around, right? So you can display this in your own econ work.
Yeah. You've kind of answered that in the first.
You basically got, yeah, you got two choices here, right? But now you can take your inverse function, right? So is this correct? So 20. I'm a little bit confused now because I don't remember if this is the one to plot. Minus 2q plus 50, is it?
Yeah, that's it. Yeah, but we've been doing that one in the first question as well.
Okay.
It's the same.
All right. So
I guess I sort of repeated myself in the question because question 1 was a bit more general, and then I got more specific in question 2. It's the same type of question.
Okay. Right. So basically what you're saying then is you just need to change the name of the letters from 2 to Q or something, right?
Yeah, that's right.
Okay. So that seems fine. So long as you're happy with it. Now, I mean, you probably want to put your P and your Q on the axis just like this. Yeah. And so, yeah, you can adjust the position of say the P and the Q on here, right? Because if we swap these, they'd end up on the other axis. Okay, now I'm going to give you another little piece of code, right? You don't need to understand this next piece of code, but what it is basically is a crude way of doing this, and I'll show you piece by piece, all right?
Sure.
So we'll be quick about it since you've got other questions. Okay, so first thing I'll do is we'll just look at the plot, right? This is the plot, and then this is your original plot here, minus 2x plus 50. And then there's a command here that says rotate. Now, what's that's doing is it's rotating the image. Yeah. All right, so I got the rotated image. So that's not quite what you want. So the next thing is, now to get this to work, I had to export the image and then import the image. Probably just because I didn't have enough time to think about it. So this is how to export an image. We talked about that last session, right? Yeah. Did we? I don't remember. Yeah.
Plot. Okay. Yeah, there was some plot.
Yeah, yes, and then so this ends up in your D folder on your Mac, whatever that's called. Yeah. All right, and then you can import the same image, provided that it's in that folder. And so here's the command to do that. Okay, now the next command here is to reflect it, right? And I'm saying, swap the left into the right and vice versa. Yeah. And this percent here just means the last thing, all right? But of course you could put this into memory, call it say G and put a G here. But the percent just means the last thing that was done. Okay. Okay, so we'll do all that and we'll see what you get. So here's the original. Here's the rotated one, 90 degrees counterclockwise. And then here's this imported one. You can see it's a bit grainy. And then here it is reflected, right? So So this is a reflection of the image itself. So it should look roughly like this, right? But of course you want to do it in a professional way, right? So I just thought I'd show you that, just so you know that, I mean, Mathematica can do some abstract things. It can basically put abstract objects into memory, and then you can program with them, which occasionally is handy. So yeah, we'll just leave that. I'll just say here, extremely crude way to do it, but interesting.
Yeah.
Procedure. Right. Okay, so let's scroll down and have a look at your next question. All right, so next question, how do I find the horizontal and vertical intercepts of this? All right, so as in where they intersect with the x-axis?
Yeah, just the horizontal, I mean, like, this is my question. As it is, f of x equals minus 2x plus 50, I can can solve for the x-intercept here. So this is the x-intercept at 25.
Okay.
But I just like it would be nice if they just showed me. It would be nice if Mathematica just showed everything to me.
Yeah. Okay. Sure. Well, we can do that. So here, I mean, obviously you can plot it and check, right? Yeah. So here we see 25, and over there we see 50. All right, but you want to actually check. So the way I would go about this is, I mean, here we can say P equals this. Now that's going to put P into memory as minus 2Q plus 50. All right, and then what you want to do is say, so replace all so that you don't put Q into memory. And then we'll just say Q goes to 0, and we'll see what we get. Whoops, replace all P with Q going to 0. Okay, so this here, you get the 50. And so you know that that's the y-intercept. Okay, so here I'll just put above y-intercept. And I guess it's the p-intercept, is it?
Yeah, it's the p-intercept.
Yeah, so let's call it the p-intercept. Okay.
Oh, no, please, just,
right, so
you can use it as y. I might get confused.
Okay, yeah, well, it's up to you. Yeah, we'll go y if you like.
Yeah.
Okay, so this is the y-intercept then. And now if you wanted to put that in memory,
yeah.
So you could just call it y in something like this, y-intercept, or you could even spell it out, right?
Yeah.
Intercept equals, and then that puts that in memory as the y-intercept that you can call on later. But it's a bit lengthy, right? So you might want to shorten it.
Sure.
Okay, so now the other one, we would just basically do the same here with the all right. So now I'm just thinking, all right, about the best way to explain this and how to deal with this here. So yeah, now the problem is I've got P in memory. Okay, so in a sense we need to rewrite this. All right, and so just go, how about little p and little q, because they're not in memory. And then we'll put an equals equals here. All right, so well, what I want to do really is replace all. Whoops, I accidentally executed that, I think. Replace all Okay, and this time we're going to replace the P with 0. Now what you just get is, okay, I misspelled it there, replace all. All right, so you get an equation there, and you can just solve that equation. All right, so we can just put around that, solve this equation. And really, since you're learning, it's probably better to just set this out. So let's say W equals that. And so the output of that is the equation, right? But then if we solve that resulting equation, now W is the equation itself, you see?
Yeah.
But we want to solve the equation for Q. All right, and you see, again, we've got the double brackets. So what we need to do, so let's call this Z. We need to extract specific elements of Z. Okay, so again, it'll be the first one here. This is the first one. Hang on, this is the first one. Then we want the first one of that, which is this, and then the second one, which is this number. So 1, 1, 2. All right, and here we get number, and so we can put semicolons around this other stuff because that was intermediate. And then we can call this result x-intercept. Is equal to the number, right?
Yep.
And hang on, where did the y-intercept go? Okay, here. So now we've got both of those, all right, the 25 and the 50.
Oh, yes, that's nice.
So, yeah, have any questions about that procedure?
No, that's fine. Thank you very much.
Cool. Now, it should work for curves as well, right?
Yeah.
And I can see that I haven't done this in the most, I guess, slick way, right? But sometimes when you think about it, you just got to think a little bit longer and you find a more slick way to come up with the same result, right?
Yes.
So I'm sure if we spent a little bit more time, we could find a better way to go through, pull out those numbers. So also this procedure should work if this is, say, a quadratic that passes through the horizontal axis,
Yes.
right? Because of course they all don't. Not all of those quadratics pass through the x-axis.
Yes.
Yeah. So yeah, you might want to try that yourself. See if you can change the function and get this to work on a different function too.
Yep.
Okay. We ready to continue with your next question?
Sure. Yeah.
All right. So here, tell me this one.
So I'll explain this one. This question 3, if we go to the next question,
Yep.
we're going to be solving question 3. So this
right.
So this is the situation. We'll use a question 4 to solve question 3. So we'll just jump to question 4.
Right on.
So I've got this
so
matrix.
You're asking how to remember? Yep.
I got this matrix A, and then I got this matrix
right, good.
B.
Looks good. Yep.
And then, well, we might as well answer the question 4 one. There's got this A dot B, which is matrix multiplication. And then I saw somebody put these 2 slashes and then matrix form. And then it creates a matrix or something. So maybe
it gives you a pretty version of right? Okay, so right. Okay, so what you're outputting here is you've got the way that Mathematica puts that in memory, right? So you've entered it in the pretty form, and you probably had to go up here.
Yeah, I
and
did.
Say insert table matrix, right? So that's convenient. But that's not the way that Mathematica deals with it in behind the scenes, you see.
Yeah.
So the way it deals with it behind the scenes looks like this, which is unfortunate to look at for a human, right? But it's perfectly fine for the computer. And likewise, this column matrix here looks like this in the code. All right. Now, if you wanted to display that in a pretty form that's nice for us to look at, well, then you just put / matrix form. That's one way to do it, right? But another way to do it is you can do it as a function as well, right? Instead. So you can just say the matrix form of A dot B, right? And it gives you the same thing. So if you prefer to do it as a function, that's fine. So what this does is it just says, apply this function to this, right? Now, sometimes it's handy to be able to do that, but I think it's maybe more organized to think in terms of applying a function to something, right?
Yeah. Yeah.
I don't know. Yeah.
You're right. It's a bit more
different ways to do the same thing. Yeah, that's right. And so, look, while we're on this topic, I'll just show you another thing. All right, so let's just build a matrix. All right, so let's just start with some random numbers. So if I just put random like this, okay, it'll give me a random number. If I do it again, I'll get another random number. All right, now if I apply a tabulation, right? So I'll just say table this, and then we'll just say I goes from 1 to 3. All right, so we'll get a list of 3 random numbers now. Do you follow that?
Yes, thank you.
All right, sure. So let's add to this, and I'll just put that below. So now let's put in a J. So J goes from 1 to 3. Okay, now you see we have something that looks a lot like what you had above.
Yes.
Okay, and let's call one M equals that. And now below, I'll say let's display the matrix form of M. Okay, and now we get a pretty form of this.
Yeah. Yeah, that's good.
All right.
Thanks.
Yeah. So of course they're different numbers than just a second ago, and you know you can take this much larger.
Yeah.
All right. So you can put 8 by 7, for example, and then you basically fill up the screen, and you can suppress this so it doesn't show, and so on here. Now, do you know about the software called LaTeX?
I don't know much about it, but it's good for creating a journal, I think.
Yeah, so it basically it makes your maths look pretty, right?
Okay.
It's a little bit complicated to learn it, but I'll just show you. You see how I've highlighted this?
Yes.
Now, if I right-click, I'm right-clicking with my mouse. Right now, I've got several options here, but if I go copy as, and I'll just click LaTeX here.
Yeah.
And then I'll just go in the cell below and press Control V. All right, so now this gives the LaTeX code for making that matrix.
Okay.
All right, of course, it's not perfect here. Like, for example, you see a little gap here between the R and the I. Yeah, so now you had a question up here, how to get that out of memory, right?
So if we go through this, I'll explain this a bit for you. That was good.
Okay.
Thank you for the matrix form function. But this A, what this is it's a matrix, but what it is, it's a can you see 0.8? That belongs to supermarket. What was it? Supermarket something.
All right. Yeah, I get your point. So basically, you've got a spread. Is that right?
Yeah. Well, I'll just explain without explaining the whole thing. Maybe I want to multiply A by B. So I put A into memory and I put B into memory. And if you scroll down a bit,
sure,
Keep going, keep going.
Okay. There might be a little bit of a lag on green, by the way.
Yeah. Can you see output 283 / matrix form? Starts with 0.295.
Yep.
Well,
that's right. Yeah.
So that's the output of that of A matrix A multiplied by matrix B. But I haven't put it into memory. But I would like to put it into memory.
Oh, I see. Okay. Right. So now, hang on. You said something about protected, right? So you might have chosen the letter C.
Yeah.
Did you choose the letter C? Okay. So C is protected. So I'll just write that for you here. Uppercase C.
Yeah.
Is protected among some other things. So let's just make the list here. Uppercase C, uppercase E, uppercase I, uppercase N. These are protected, right? Because they want to use them for particular things like the speed of light for C. Euler's, I guess, you know, the base of the natural logarithm, 2.71828, etc. This one, the square root of -1, and this for the function that takes the numerical value.
Yeah.
So each of these are protective. So you got to get creative here. So let's just put, now C and G look similar, so I tend to use G.
Yeah.
All right. So we'll just write G equals A dot B. All right, and then we'll just say matrix form G.
Yeah.
So in memory is G, okay? So yeah, here's evidence, right? Because we called on it and it displayed that.
Okay.
All right, but you had a question about taking things out of memory. So now we can go clear all A, B, and G. And now you can see they're blue again. So now those are not in memory after having done that calculation because the clearing of it happened at the end.
Okay. Okay.
Right. So for example, if you say, what is A? It says, I don't know, it's just A.
Okay. Okay. That was interesting.
You follow that?
Yeah, that was interesting.
So yeah, that's how you write certain variables. Great, good. Okay, you ready for another question then?
Yeah, I think that was the last one, maybe.
Oh, was it? Okay, I got a little quick. All right, now use the output of the above line to determine another product matrix. All right, so hang on. So this is, oh yeah, so basically, so what you want is something like A dot. So you're taking A squared times G, I guess, right? Or A squared B. And then I'm going to display that. Oh, what have I done there? All right, so G was erased. So we'll take that out there. Keep G in memory, and then we'll use it here. Oh, right, A as well. All right, so we'll clear B. We'll just clear B. Now, hopefully this goes through. Okay, great. All right, you happy with that one?
Yeah, I'm very happy now. Thank you.
All right, awesome. Okay, so let's scroll down. You want to use it again? So that's the question, is it?
Now, I was just trying to explain, like, you've done it nicely. I wanted to use the shortcut A, you know, you wanted to use A dot G and things like that instead of A dot and then the matrix. It doesn't look as clean.
Yeah.
That's it.
Okay, right. Yeah. Okay, so let's see if we can work out matrix powers while we're here, right? Because, I mean, that's what you're doing essentially. So you've got A dot B, but hang on, we need, let's go clear all F there.
Maybe we can do like a bit of determinants if we have time, or I don't know.
Okay, sure thing. Yeah. But anyway, what I was about to say is there may be a built-in way here to do powers of matrices that I don't know off the top of my head, because that's essentially what you're doing here, right? So you've got A times B, and then you want to multiply by another A. So so you see how this is the same.
Oh, okay.
So we'll just write matrix form. Yeah. Okay, we probably have time just for me to look this up, all right?
Sure.
And then we'll go on to determinants. So we just write matrix power. A comma 2, is that right? Okay, and then dot B, matrix form. Okay, awesome. So you guys need to do that calculation. You see that?
Oh, okay. Okay.
So yeah, that's the matrix power. So A times A, so A to the power of 2. Of course, you can't just put A superscript 2 and hope for, you know, so 2 to the power of 3, right, is 8. Whoops, that's not a 2. But you can't do that with a matrix, right? So if I went to A to the power of 2 like this, well, maybe it does work. Okay. A little surprised here. No. Okay. Yeah. So what this has done is squared every element of A. Let's just say, okay, squares each element of A, but is not A times A. So just be careful, right? In case you needed that one day. All right, so you want to talk about determinants now. So in Mathematica, that's fairly simple, right? So you just have this det A, for example, and it just calculates that determinant for you. Now, do you know the lengthy formulas for determinant calculating?
No.
No, okay, so they can be, well, all right, in terms of a 3 by 3, I'll just give you an example, and I'll just pull up a palette to show you. So we'll go table matrix, new, 3 by 3. And so we'll just put this in symbolically. Okay, now you see how the A, B, and the G are black in color, but the rest of the letters blue?
Yeah.
That's saying the A, the B, sorry, the A, the C, and the G are in memory as numbers. And in fact, if I do this, you see there, it's these particular numbers, I guess, or things. Now, so what I want to do to get rid of those out of memory, now if I do this, it clears everything out of memory, right? So use it with care. So I'm going evaluation, quit kernel, local. Do I really want to quit the kernel? Yes, quit. Okay, and then it goes this darkish blue color, and then I press the button again. That starts up the kernel, right? But it takes a long time this time because it's got to start up the kernel. That's okay. I mean, it doesn't take that long. So here we go. So that's in memory. And now if I just say take the determinant of this, it'll give you a symbolic determinant, you see? So this is a formula for the determinant of a 3 by 3 matrix. But you can calculate in the following way, right? So it's A times the determinant of this smaller matrix, and I'll just delete some rows. I'm deleting the row A is in and the column that A is in. All right, so it's A times this determinant, and then the next one is minus B, and then we take another determinant obtained by crossing out the row and the column that B is in. We cross out the row, now we cross out the column. Okay, and now we have this, and then it's plus C, and then we have another determinant. And so this time we cross out the row and the column that C is in. and we get the same expression here, except this time we need to see that those are the same. We can expand this, right? And then we get this same symbolic determinant for those, right? So this is the way that you do that calculation by hand, right? Okay. You go top row, you'd alternate with the sign, and then you calculate the subdeterminants, right? Which is just this one, E times I minus F times H for the 2 by 2 determinant. So I guess we better do a 2 by 2 determinant for you as well. Just so you can see what the determinant of A, B, C, D is there symbolically. So AD minus BC.
Okay.
All righty. And so, of course, this works with numbers as well, right? But you probably, I mean, since you're doing an economics course, you're going to want to do a few calculations by hand. And I guess probably you'll be doing some 3 by 3s. Now, of course, you can take the determinant of a square matrix of any particular size, right? But to do it by hand, it becomes rather a lot of work to do that by hand, right? So there are some more sophisticated techniques for calculating determinants, but you probably learn those in your course, maybe. I guess we'll see. Yeah.
Oh, thank you very much.
All righty. Any questions? Yeah. Okay. Hope you got something out of it.
Yeah, I got a lot. Thank you. Okay.
All right, mate. So, did you want to meet up again?
Yes. We can meet up next Wednesday.
All right. Same time?
Yeah, same time.
Yeah, I am. Okay. All right. Wednesday, same time. All right.